Hi everyone, thank you for watching my presentation. I am Vishesh from University of California, Berkeley. I wrote this paper along with Professor Tommelein and Bardaweel. So the aim of this paper is to develop an interactive visual tool for task planning. This tool is used to find the optimal workload level and associated workspace zoning, and also in turn help the planning team to set the task duration. To be clear, this tool allows the teams in the initial part of the task planning process and not the complete process, which might include scheduling and controlling of the plan. So the tool is using work density method, um, and developments in using this method are also part of the study, which was done through a design science research process. Um, Data from two projects in San Francisco Bay Area were taken to prototype several iterations of this tool, and then the final version of this tool is presented here. We call the tool Vivolzo, which stands for Visual Workload Leveling and Zoning. So to give some background on the research, we are working with location-based planning. There are several methods that allow planning by location, and sometimes even project teams don't use any defined method and just divide the workspace into areas to allow parallel work. It is beneficial to them as crews can work concurrently, yet not be in each other's ways, shortening the construction schedule and increasing the overall productivity. So often the rationale for such division is not well articulated, as this is not as this mostly project specific and experience and circumstance driven. Sometimes the division is simply dividing the floor into halves and quadrants for simplicity, and minimal to no data um, is used to complete this work and make such decisions. And this can obviously result in uneven workflow among the spaces as they will have different amount of work. And this is where task planning comes in, which is also a location-based planning method, scheduling space along with time. But an important objective of task planning is to deal with the unevenness in a production system and to create flow. This is achieved through structuring the work so that tasks can be completed within the time of a regular beat based uh, determined based on our customer demand, which trades involved in this task will moving through the space sequentially from zone to zone. Um, the desire to plan work to a regular beat is challenged by the fact that construction work tends to be non-repetitive and production rates may vary by crew size, scope of work to be done in an area, means and method, and many more factors. One of these challenges, um, um, one of the ways this challenge is addressed is using the work density method, which we have been used here. So there's the basic definition of work density method. Um, it uses work density, which describes how much time a given trade will require to do their work in that area, based on the product design and scope of work done by the trade for a given task in the schedule. It is a mathematical concept and is represented by a numerical value. Being generic and simple numeric value, work density compiles specifics of several production system throttles, describing what work will be done by whom, where, and how. Um, it is also location specific as it can change depending on the type of space and also the size of space. It is process specific as it is expressed in terms of the work that is included in a given step for process. It can be added together, so it is additive. Different types of works can be aggregated into one step. Um, um, for example, mounting a sink in a kitchen uh, can be separate steps from actually mounting the faucets and connecting it to the plumbing system. Alternatively, both of these steps can be combined together, and if so, then their work densities can be simply added. So, coming to the case studies which we conducted during the research, um, in order to study how a project production system using workload leveling and zoning may be implemented in practice, we conducted our research on 2 projects in San Francisco Bay Area in California. For study 1, the focus was on takting the process involving interior trades, um, namely those working on the overhead system, interior walls, plumbing, electrical, framing, etc. Um, and this was on a multi-story medical office building with repetitive floors from 2 to 5. So then we studied another project which is shown here. This facility is a mixed-use building housing teaching, research laboratories, conference rooms, administration offices, and clinics. The building has several parts, out of which we studied the 12-story tower, which has repetitive floors from 6 to 12, and they were um, modeled in the tool with one floor as a representation for the whole tower. So now coming to the tool itself, we started with defining the process steps by holding team discussions. In relationship to the production system design, we asked the team several questions which help us define these processes. Questions included in what units will the work be assigned to the group of workers, how will the work be sequenced, and how will work be released from one group of workers to the next. Will the consecutive group of workers execute work in a continuous flow process, or their work will be decoupled? And several questions like these help us um, create these process maps. With these questions in mind, different workspaces are identified for which the team defines these processes. In the second case study, these spaces included corridor space, open areas, office spaces, and bathroom. So each step will be performed by a single crew of or trade partners based on their designated scope of work and how that work is structured. The identification of process and spaces tends to require iteration, um, and the figure here shows the process map for a corridor space from the second project that we studied. Here, the steps are color coded to identify which trade partner is in charge. For example, blue here depicts electrical specialty contractor. Similarly, jointly with the project team, we created process maps for several unique spaces identified on a typical floor. So creating process maps for different project spaces allows the team to explore alternative steps with their sequencing and to identify different crews and their scopes of work in the process. Each trade must provide data pertaining to the production rates and work quantities for these steps. So coming to the um, data collection part, other than the process maps that tell us the processes and their individual steps, we need to calculate the work density for each of these steps identified, for which quantity of work and production rate is required. This has to be done upfront and with the trades involved. For the production rate, discussions with the trades and the crews tell the expected value, which might come from their historical data or experience. For the quantity of work, tool takes floor plans from various types of work and takes the quantity takeoffs from there. Here are 2 examples where fire alarm plan on the left and the electrical wall device and on the right are shown. In the figure, fire alarms, there are 3 fire alarms and then 3 low voltage dimmers are identified in a particular cell, which have to be installed during a particular step. With the quantities of work in each cell, the production rate is multiplied to calculate the work density for that cell. This is repeated for each process steps and for each cell on the floor. Thus, cell definition becomes an essential part of how the tool works. So cells are the basic unit that make up zoning for Takt plan. A zone can be one or several cells combined, and the novelty of this tool lies in its support for users to try different zoning scenarios using these cells. In the research, we focused in the interior finishes, and thus we wanted to be able to align these grids for the cells with the architectural features such as the walls of rooms or open spaces. So we allow the grid spacing to vary. Different types of spaces also dictated the borders of cells that are at the intersection of these spaces. If a wall needs to be worked on from both the sides, assigning one of its sides to one cell and the other side to the another cell could lead to incorrectly capturing work density values. So instead, both walls may have to be included in the same cell. Such preferences in tackling work for better performance and safety have to be incorporated by talking to the team. In the project studied, inspection was the main customer downstream, and thus their preferences in defining workspaces were important to be incorporated in cell grid definition. Also, as the size of the grid changes, like final grid size will provide more cells and more flexibility, but also require greater upfront effort to set up the tool. Depending on the phase of the project, the people involved and the rationale for defining cells will vary. With unit cells defined, work density calculations then require the production rate and the product quantities tied to each cell for each step in the process. So for the Vivaldo dashboard, it basically acts as a visual control for the purpose of defining the zone. The zoning input tool on the right allows the user to assign numbers which with each one assigned to a unique color to each cell to designate which zone it belongs to. The tool then filters all the work density underlying the dashboard based on the zoning on the left and adds up the work densities in the cells of each zone and plots the workload on a histogram. To give you some perspective, there were 267 different cells for 19 different steps. Thus, total of 5,063 work density values were produced. Here you can see that zones 1 to 5 are the actual zones, while more number of zones are provided, which allows the user to designate cells with work that is not included in the process. Example, vertical spaces like stairs, elevator core, electrical room, mechanical shafts, IDF rooms are given zones from 6 to 8. Basically, these zones may be built according to their own schedule and may not be part of the Takt. So they can be removed from the workload leveling process. So from the work density map described just now, the histograms plotted where the work densities are grouped by zone. By changing the number of cells in the number of zones, the Vivaldo user can level the workload for each trade within each zone. Leveling is likely to require several iterations of trial and error. The real-time visual representation of work densities will indicate if a better zoning map may be possible. Because zoning is done manually, the user can incorporate site-specific constraints and reflect their preferences in zoning. So initially, the project team had divided the floor into 4 quadrants: zone 4 to zone 1 to zone 4, and the 5th zone being the bathroom. and thus obtain the histogram shown here. Using the tool, the team reassigned zones to 46 cells and changed the crew size by adding 7 new members and removing 4, thus changing the production rates and obtained a much more balanced histogram as shown here. It also reduced the peak and thus lets the team to set a lower takt if they want. So the whole workload leveling process is done through iterating through the leveling of these bars. Zones where the work density is low, the bars can possibly be raised by increasing the number of cells included in that zone or by reducing the production rates by downsizing the associated crew. Similarly, where the work density is high, the bar can be possibly be lowered by reducing the number of cells in that zone or by throttling up the production rate by increasing the crew size. Allowing for iterations of trial and error in leveling within and in between the trade and process levels, we've also real-time visual depiction of work densities helps the user to make data-driven zoning decisions and to set the takt. For this workload level distribution, the team gets the zoning layout and also an idea about how and where to set the takt. The takt should be a little higher than the peak bar from the histogram, as that allows the team to give some buffer capacity to the crews. So from the experience of developing this tool, we learned and identified areas of improvement for the future. Some of them, the major ones are explained here, where we definitely need early collaboration and data collection, which should be managed by a person internal to the project team, like a superintendent. The GC, along with the participating trades, should own the planning effort, contributing and understanding the process and the handoffs between the steps. They should be prepared and possibly incentivized to participate in this process, and they need to be open to sharing their production rates from the past projects. A streamlined data collection process can reduce rework and upfront effort in collecting and setting up the data. Also, work structuring and capturing process capabilities, something that will require work for future. There are several work structuring decisions that can be made in course of takt planning at the operational level. For example, if one trade's work density peaks above all others, the bar may be split into 2 or more individual bars so as to give the trade more than one takt to complete their work. Being able to include such decisions based on the process capabilities can allow more flexible planning for future. Other avenues of research can be improving the application of technology being used. Like BIM tool can be used to collect work quantities by element or by space. And the whole process of workload leveling and zoning can be automated using optimization algorithms. So to conclude from this research, and with the tool, we were able to produce a visually representation of work density maps. This allowed us as well as the project teams to explore alternative scenarios of zoning and workload leveling by varying the crew sizes and production rates for multiple trades. And it supported the what-if analysis to set takt and even reduce it if that is needed. The what-if analysis was essential as teams can easily identify, check with different zoning scenarios and see what impact it has on distribution of work. The zoning and the leveling process was completely data-driven, but could be easily worked on without going through the vast amount of underlying data. Thus, for the project team, it saves time while planning and also increases their efficiency and accuracy. So I would like to say thank you and for watching my presentation. That's all from me. for now.